In today's video, we are going to look into next few questions of the chapter Some Basic Concepts of Chemistry. The first question is question number 6 from the Ncert textbook, and the question says, calculate the concentration of nitric acid in moles per liter in a sample which has density 1.41 gram per milliliter and the mass percent of nitric acid in it is 69%. So, in this question, we are asked to calculate the concentration of nitric acid and we are given the density as well as the mass percentage of nitric acid. It is given the mass percentage of nitric acid as 69%, which means in a 100 gram of nitric acid solution, it contains 69 gram of nitric acid by mass. Next, we have density as 1.41 gram per milliliter. We all know that density is mass by volume, from which we can calculate the volume as mass by density. Now, let us calculate the volume of 100 gram of nitric acid solution. Nitric acid solution, which is mass by density. We know the mass of the solution is 100 and the density which is already given us 1.41. So, we have the answer as 70.92 milliliter. Now we have to convert it into liter, which gives us 0.07092 liter. To convert milliliter into liter, we have multiplied it with 1000. To calculate the concentration of HNO3, that is nitric acid, in moles per liter, we should know the number of moles. So, to calculate the number of moles, we should be first aware of what the molar mass of nitric acid is. So, the molar mass of nitric acid is the atomic mass of hydrogen 1 plus nitrogen 14 plus 3 into atomic mass of oxygen, that is 16, which gives us 63 gram per mole. So, this is the molar mass of nitric acid. With this information, we can calculate the number of moles or the moles of 69 gram HNO3. That is, the given mass of nitric acid is 69, which we have obtained from the mass percentage concept, divided by the molar mass, that is 63, which gives us 1.095 mole. So, this is the number of moles. So, to calculate the concentration, we have number of moles as 1.095 divided by the volume, which we have calculated to be 0.07092 liters, and that is 15.44 molar. So, we have the answer as 15.44 molar, and that is the concentration of nitric acid in moles per liter. Question number 7 says, how much copper can be obtained from 100 gram of copper sulfate, that is CuSO4. It is also given the atomic mass of copper as 63.5 atomic mass unit. So, first let us calculate what the molar mass of copper sulfate is. So, we are going to calculate the molar mass of copper sulfate. That is, the atomic mass of copper is 63.5, which is already given. Then sulfur, we know that is 32. And we have 4 atoms of oxygen. So, we multiply 4 into 16, that is the atomic mass of oxygen, which gives us 159.5 gram per mole. So, this is the molar mass of copper sulfate. We know that in 159.5 gram per mole of copper sulfate, we have 63.5 gram of copper, which is very evident. Now, we are asked to calculate how much amount of copper will be there in 100 gram of copper sulfate. So first let us calculate in the case of 1 gram. What if we are having 1 gram of copper sulfate? That will be 63.5 divided by 159.5. So, for 100 gram of copper sulfate, the amount of copper will be 63.5 divided by 159.5 into 100. Solving this, we have 39.81 gram. So that is the answer for this question. Question number 8 says, determine the molecular formula of an oxide of iron in which the mass percentage of iron and oxygen are 69.9 and 30.1 respectively. Given that the molar mass of oxide is 159.8 gram per mole. The atomic mass of iron and oxygen is also given in the question. So here we are asked to calculate the molecular formula. So what is this molecular formula? Molecular formula gives us the exact number of different atoms present in a molecule. So here we know that it is an oxide of iron. So the atoms present are Fe and oxygen. So the molecular formula helps us to calculate the exact number of atoms of iron and oxygen present in this oxide of iron. To solve such a question or to find the molecular formula, the first thing we have to calculate is the empirical formula. Empirical formula gives us the simplest whole number ratio of various atoms. That is, it doesn't speak exactly about the exact number of atoms but gives us a simplest whole number ratio of the different atoms present. So, to solve this, let us first find the empirical formula. To calculate the empirical formula, let us follow this tabular method, wherein we have the element, symbol, percentage by mass, atomic mass, moles of element, simplest molar ratio and the simplest whole number ratio. So the elements here are iron and oxygen. We know the symbol of iron as Fe and oxygen as O. So the percentage by mass is given in the question, which is 69.9, and for oxygen it is 30.1. The atomic mass again it's already given in the question, which is 55.85, and for oxygen it is 16.00. The moles of element, to calculate this, we have to divide the percentage by mass with atomic mass. So we have 69.9 divided by 55.85, which is 1.25. And for oxygen it is 30.1, which is the mass percent, divided by the atomic mass, which is 16.00, which gives us 1.88. Here 1.25 is smaller than 1.88. So we divide both 1.25 and 1.88 with 1.25. So we get this as 1.25 divided by 1.25, which is 1, and 1.88 divided by 1.25, which is 1.5. Now the next column is to calculate the simplest whole number ratio. So this is in decimal. We have to convert this as a whole number. So when we multiply one of the atom, that is oxygen's molar ratio, with 2 to make it a whole number, we have to do the same with the other element. So what do? To convert this molar ratio into simplest whole number ratio, we multiply both 1 and 1.5 with 2. So this will become 2 and this will become 3. So we get the empirical formula as Fe, there are 2 atoms, and oxygen, there are 3 atoms, as Fe2O3. So this is the empirical formula. Now in this question we are asked to calculate the molecular formula. So to calculate the molecular formula, we have to calculate what N is. N is the molar mass divided by empirical formula mass. the molar mass which is already given in the question, which we know that it is 159.8. Now we have to calculate what is the empirical formula mass. We know the empirical formula as Fe2O3. So we calculate the empirical formula mass as 2 into atomic mass of iron, that is 55.85, plus 3 into atomic mass of 16, that is oxygen, that is 16. So we get the answer as 159.7 gram per mole. So this is the empirical formula mass of Fe2O3. So we divide this 159.7, which is 1. So we get the value of N as 1. So the molecular formula for this oxide of iron is the same as the empirical formula, which is Fe2O3, because N is 1. What if in a case we have N is 2, we will have to multiply it with 2. Since we have 1, the empirical formula and the molecular formula for this oxide of iron remains the same, and that is Fe2O3. Question number 9 says, calculate the atomic mass, that is average, of chlorine using following data. And the data is 35 chlorine and 37 chlorine with their percentage natural abundance and molar mass. So, here we have two isotopes of chlorine and we are asked to calculate the average atomic mass of the chlorine. So to do that, we should first calculate the fractional abundance of each of this isotope of chlorine. So first let us calculate the fractional abundance of 35 chlorine, which is 75.77 into 100. We are multiplying the percentage natural abundance with 100 to get the fractional abundance. So we get this as 0.7577. Similarly, the fractional abundance of 37 chlorine, we again multiply this natural abundance of 37 chlorine with 100 to get the fractional abundance, and that is 0.2423. Once we get this information, we are asked to calculate the average atomic mass of chlorine. What do? We multiply the fractional abundance of each of this isotope of chlorine with its molar mass and add them together. So let us write it as an equation first. We multiply the fractional abundance of 35 chlorine with its molar mass and we add that with the fractional abundance of 37 chlorine multiplied with its molar mass. Now let us put the values. Fractional abundance of 35 chlorine, which we have calculated to be 0.7577, multiply it with the molar mass, that is 34.9689, and let us add this with the fractional abundance of 37 chlorine, which is 0.2423, multiplied with its molar mass, that is 36.9659. So we get this value as 26.4959 and this value as 8.9568. Adding these two together, we have our final answer to be 35.4527. So this is the average atomic mass of chlorine. I hope the questions that we solved today is clear. If there are any doubts, you can come and comment in the comment section and let us know. Thank you for your time.